In this video, we're going to look at a different method for factoring trinomials, and I'm going to call this the box method. This is actually a variation of the AC method if you're familiar with the AC method. But with the box method, it kind of takes out the factor by grouping step, which can be confusing for some people. So let's take a look at this example. We have 9x squared minus 8 minus 21x, and what we want to do is factor that. So the first thing that you always want to do is write your trinomial in descending order of powers. So we need to write this as 9x squared minus 21x minus 8. And a lot of times they come in descending power already, but sometimes they don't. So like the AC method, we need the values of a and c. Let's refresh ourselves on what the AC method is. So if you have a trinomial in this descending order, ax squared plus bx plus c, a is the coefficient on the x squared term, b is the coefficient on the x term, and c is the constant term. In the AC method, your first step is to multiply a times c, and then figure out two numbers that will multiply to be that product and add to b the value of b. Add to come up with the b value, the coefficient on the x term. So it's going to be the same step with the box method. Over here in our example then, our a value is 9, our b value is negative 21, and our c value is negative 8. We want to take a times c. We're going to set up this little triangle thing here. So a times c, 9 times negative 8 would be negative 72. So we have to figure out two things that multiply together to be negative 72 and add to be negative 21. So that might take a little fishing around with negative 72, but if you work on it for a little bit, you are going to come up with negative 24 and 3. Those add to be negative 21, and if you multiply them together, you get negative 72. So far this is the same as the AC method. Now here's where it goes different. So with the box method, what you do is you take your first term, which is going to be your x squared term, and you always write that in the upper left hand corner of this box. So this box is always going to get set up the same. It's a rectangle cut into 4 pieces. In the lower right hand corner, you're always going to put your constant term, which in this case is negative 8. Now, after you do this little triangle step and you come up with your negative 24 and your 3, what you do is you put those in the other two boxes, and it doesn't matter what order you put them in. You could put them either way, and you put an x term on them. Okay, so I have my x squared term here and my 8 here. I'm going to take my negative 21x and I'm going to split it up to negative 24x and 3x, and I'm going to put those in these boxes. So I'm going to put my 3x here and my negative 24x here. And like I said, you could switch these and it wouldn't matter. Alright, so now what you do, let's do this in a different color, is you look at the 9x squared plus the 3x, this top row. I'm saying plus because this is positive. And I ask myself, what's the greatest common factor between these two terms? And they have a 3 in common and they have an x in common. So I'm going to write that outside here. Now on the top of the box, I'm simply going to write what would multiply with 3x to give 9x squared, and that would be 3x. So if you think of this as like the area of a rectangle, 3x times 3x is 9x squared. So this distance right here, I'm thinking this as 3x. Alright, so this is 3x. And what would I have to multiply 3x by to get 3x? Well, that would be a positive 1. So I put plus 1 up there. So now if you think of multiplying or distributing 3x times 3x is 9x squared and 3x times 1 is 3x. It's kind of like taking out a greatest common factor. Alright, well now we can take this 3x right here, which also corresponds to this length, and we can ask ourselves 3x times what would give us negative 24x, and that would be negative 8. And you can also see that that's the greatest common factor between these two terms on the bottom row. So you could also ask yourself, what's the greatest common factor between these two terms on the bottom row? And that would be negative 8. And if I take that negative 8 out or divide it out of negative 24x, I would get a positive 3x. If I take it and divide it out of the negative 8, I get a positive 1. So if you see, these things all multiply together like little areas. Negative 8 times 3x is negative 24x. Negative 8 times positive 1 is negative 8. And we talked about the top row before. So what you have in terms of area, if you look at the length of the top, you have 3x plus 1. And if you look at the width of the side here, or you could think of it as the height, these parentheses are going to look a little weird, but that's okay. We have 3x minus 8, and these two things multiply together to give this area. So in other words, we know that 3x plus 1 times 3x minus 8 will give us this area, which corresponds to this trinomial. So there it is. It's factored. All right, so let's look at those steps one more time before we do another example. And then we should probably check this, but it's kind of checked right here. Make sure you're in descending order. Set up your AC method, just like you did before. Take A times C, figure out what multiplies to be AC and adds to give B. Set up your box. Put your x squared term in the upper left, your constant term in the lower right. Your two numbers you found down here with x's, that's key, they got to have x's in these two boxes. And then you do a greatest common factor of each row, and it should correspond to these column values as well, so that they multiply together to give the area of each individual box. What's on the top and the side on the outside are your factors that multiply together to give your trinomial. So if we wanted to check this, this is our answer. This is factored. If we wanted to check this, we would just FOIL. So 3x times 3x is 9x squared. 3x times negative 8 is negative 24x. 1 times 3x is positive 3x. 1 times negative 8 is negative 8. And if you'll notice, these four terms correspond to the four terms in the box. Not a coincidence. And then you could combine like terms. And when you're combining these two like terms together, you're just basically doing what you did over here. You picked negative 24 and 3 because they combined to be negative 21. And so you end up with the correct trinomial. All right, let's do one more example. It's always good to do multiple examples. Let's see. And if you think you got the hang of this, you might pause the video and try it yourself. Let's delete this here. Let's see. Okay. I need my keyboard. All right, and we'll delete this down here. Let's try 6x squared. So we're going to factor 6x squared plus 13x minus 5. All right, so if you want to take a shot at this, go ahead and pause the video and then start it when you have your answer. So the first thing we need to do is, well, we could set up our box, or we could do the AC method thing. I'll do the AC method thing first. So my A value is 6, my B value is 13, my C value is negative 5. So A times C, 6 times negative 5 would be negative 30. I need to come up with two numbers that add to be negative 30. I'm sorry, multiply to be negative 30 and add to be 13. Positive 13, and that is going to be 15 and a negative 2. 15 times negative 2 is negative 30. 15 plus negative 2 is 13. So now I have all the information I need to set up my box. So I'm going to set up a box. I would do it here. A purple one. Okay. And we'll put a line this way and a line this way. And in the upper left-hand corner is going to go my x squared term. In the lower right-hand corner is going to go my constant term. And you need those signs. If it's a minus 5, you got to have that negative 5. And then I'm going to put the 15 and the negative 2 in one of these two places here. I'm going to put the negative 2x here and the positive 15x here. And you have to remember to put these x's, because what you're really doing is you're breaking up this 13x term into 15x minus 2x. Okay, so now we need to do the factoring business. What goes into both 6x squared and negative 2x? Well, 2 goes into 2 and 6, and they both have an x. So now I'll figure out what goes on the top. 2x times what is 6x squared? That would be 3x. 2x times what is negative 2x? That would be a negative 1. Now I can use these top values that I've figured out to figure out this side value, although you could say what do 15x and 5 have in common, which should be 5. But you could also say that whatever I put here times 3x has to be 15x. Well, that's going to have to be a 5. 5 times 3x is 15x. And then you could check and make sure that it works for the last one. 5 times negative 1 is negative 5. So you have your outside values. On the top, you have 3x minus 1. On the side, you have 2x plus 5. And those are your two binomials that multiply together to give 6x squared plus 15x minus 5. So that's kind of nifty. It takes out the whole factor by grouping step, which, you know, a lot of people might like. So let's check this just to be sure, although the check is right here, if you can see it. If I FOIL these, I get 3x times 2x is 6x squared, right there. 3x times 5 is positive 15x, right there. Negative 1 times 2x is negative 2x, right there. Negative 1 times 5 is negative 5, which we have there. And if you combine the two middle terms together, you will get 6x squared plus 13x minus 5. So there it is. I hope that helps, and that maybe this box method might save you some trouble if you're having trouble factoring these more difficult trinomials the other way. Remember, this really is the best method to use if your a value right here is not 1. If your a value is 1, if you have a 1x squared, much easier way to factor this, which hopefully you'll see in a different video. You could use the box method, though. This will work for any of these type of trinomials.